Hello folks, we come to the part 5 video of this exercise 5.1 and this is going to be check my connections. So and this is going to be your 12th problem that we are going to do. The 11th problem we had already taken up in the previous video. Here again it's checking the point of discontinuity. You are given the function which is breaking at 1. So we will check the, as usual, we'll check at 1 and then we will generalize whether it is going to be continuous or not. So we'll first understand the domain. Here we have 1 and on this side of 1 the function is defined as x less than 1, it is defined as x raised to 10 minus 1, and on this side it is defined as x squared. So at x equal to 1 we are going to check, consider the limit as x tends to 1 minus f of x. That means on this side, that is limit as x tends to 1, it is x raised to 10 minus 1. The moment we write the function, there is no need to write that 1 minus and all that, then only the number is enough. So that means x tending to 1, close to 1, can take the value 1. So it is like 1 raised to 10, and 1 raised to anything is 1 itself. So it will come to 1 minus 1, 0. Okay, then we take the other side and limit as x tends to 1 plus f of x. That is limit as x tends to 1 and the function there is x squared. So like that it is 1 squared, which is 1. Now that is 0, that is 1. Right away. Therefore, limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. Therefore, f is discontinuous at x equal to 1. That's it. So once you have got it, and the other places it will be continuous. So we will not get points of discontinuity. Over here it will be continuous. So if you want, you can mention that at x less than 1. F of x is a function, x raised to 10 minus 1 is a polynomial function, so it will be continuous, means there is no point of discontinuity. Is a polynomial function, therefore continuous. So you don't have any point of discontinuity there. At x greater than 1, function is defined as x squared, that is also a polynomial function, and therefore it is, a function is continuous there. So the only point of discontinuity is at x equal to 1. That is what we come to. Now the next question, till this we were only finding the points of continuity. Now next question they are asking us to, in general, find continuity. I don't know what is it after that. Yeah, discuss continuity. That's how the question is. So we'll take this and we'll, as usual, we'll first understand the domain. At 1 we have, on this side of 1 we have f of x defined as x plus 5. And on this side we define it as x minus 5. So it's at 1, there is a problem. So we will take x equal to 1 and try to find the limits on both sides. Consider the limit as x goes to 1 minus f of x. That means on the left side of 1. On the left side of 1 the function is defined as x plus 5. X is tending to 1, very close to 1, 1 can be substituted. So it is 1 plus 5, 6. And we'll go to the right side. Limit as x tends to 1 minus f of x. That means limit as x tends to 1. On the right side of 1 the definition is x minus 5. So 1 minus 5, it is minus 4. Am I correct? I have to check the definition. Yes, x minus 5, yes. So 6 at minus 4. So therefore, not same. Therefore, limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. Like that, f is discontinuous at x equal to 1. Now, as usual, now we have got tamed with this idea. At x less than 1, how is the function? Function is defined as x plus 5, which is a polynomial function. So, f is continuous. Then at x greater than 1, this is how we discussed. We have discussed at all the points. F of x is x minus 5. That is also a polynomial function. Therefore, f is continuous there also. Right. So that's about it. So that's how we cover all the prospects. Now we go to the problem number 14 and we'll see the but there are too many breaks. So 2-3 places we'll have to check. So it is like this, that we have from 0 to 1. Then we have from 1 to 3, then we have from 3 to 10. That's how the domain is defined. In this range, the function is defined as 3. They are all constant functions. Here it is defined as 4, and in this range it is defined as 5. This is how the function is. So there is a change around 1 we will check, and around 3 we will check, because changes are happening at those areas. So at x equal to 1, let's check. At x equal to 1, let's consider the limit as x tends to 1 minus 1 from the left side. Just check. It is 3. So answer is 3. And limit as x tends to 1 plus f of x. That means from the right side. Right side of 1, the function is 4. So value is 4. So just check around 1, both sides the values are different. So they are not continuous, right? So therefore limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. So therefore f is discontinuous at x equal to 1, right? Then we will also check around x equal to 3. So consider the limit as x tends to 3 minus f of x, means left side of 3. What is happening in the left side of 3, it's very clear to us, is 4. Value is 4 because it's a constant function. And limit as x tends to 3 plus. That means on the right side of 3. Right side of 3, the function is 5. Again, they are not same, right? So therefore what will happen? Therefore limit as x tends to 3 minus f of x is not equal to limit as x tends to 3 plus f of x. Like that, f is discontinuous at x equal to 3. So at two places, and like before, we don't have to do x less than, all that is not required, because our domain is only from 0 to 10. They have defined only from 0 to 10. So we don't have to look elsewhere, and amongst this existing domain at 1 and 3 it is discontinuous. That is what we found. Okay, now once we are done with that, let's move to the next question. That is also this not one break point, there are 2-3 break points. So let's see how this comes. Here we have 0 and 1, yeah. So here the function is defined as 2x. Here it is defined as 0, and here it is defined as 4x. So let us see how to go about it. First at 0 and at 1 we will check at x equal to 0. We'll see what happens. Consider the limit as x goes to 0 minus f of x on the left side. On the left side it is defined as 2x. So that is 2 into 0, x tending to 0. So 2 into 0, that will be 0. And limit as x tends to 0 plus. That means on the right side of 0. It is 0, constant function, that is also 0, and f of 0 is also 0. Yeah. So limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is f of 0. So f is continuous at x equal to 0, right? Then we can move to x equal to 1. Let's see what happens. Limit as x tends to 1 minus, means left side of 1. What is the function defined as? On left side of 1, the function is defined as 0. And on the right side of 1, the function is defined as, on right side of 1 it is defined as 4x. Which means x tends to 1 means 4 into 1, 4. The values are not same, right? We see that limit as x tends to 1 minus f of x is not equal to limit as x tends to 1 plus f of x. Therefore, f is discontinuous at x equal to 1. At x equal to 0 it was okay, but at x equal to 1 it is discontinuous. And if you want, you can tell about x less than 0 and greater than 0 also. At x less than 0, the function is 2x, which is polynomial. Therefore, f is continuous, right? And at x greater than 1, f of x is defined as 4x. That is also polynomial function. So f is continuous. That's it. So that's how they ask us to discuss. That means throughout we'll see where it is discontinuous and where all it can be continuous. That's all about this. No problems. We are coming in the next video. Thank you.